July 2025, a network of telescopes across the Southern Hemisphere locked onto something that shouldn't exist. A visitor from the dark between stars, moving through our solar system at impossible speeds. Following a trajectory so precise, it seemed almost deliberate. At first, astronomers thought it was just another comet, but with every observation, the rules began to break. Its chemistry didn't match anything in our catalogues, and its path through space raised questions no one was prepared to answer. This wasn't just another rock from the void. This was 3I Atlas, and it was about to rewrite everything we thought we knew. Before 3I Atlas, humanity had confirmed only 2 visitors from interstellar space. Oumuamua in 2017, a tumbling enigma that vanished before we could understand it, then 2I Borisov in 2019, carrying a chemical signature from another star system. Both raised profound questions, and both disappeared before we could answer them. But 3I Atlas was different. Larger, brighter, and for the first time, accessible enough to study in detail. It gave scientists something they'd never had before: time. The deeper astronomers looked, the stranger the answers became. The detection came from the Atlas Survey Network, a faint speck drifting from the galactic center. Then the trajectory calculations came back. Hyperbolic, retrograde, not bound to our sun. This was something from beyond, cutting through our cosmic neighborhood at an angle just 5 degrees off the ecliptic. The James Webb Space Telescope, Hubble, ground-based infrared arrays, and every instrument began gathering data. But as the data poured in, excitement turned to confusion. The comet's coma was brighter than it should have been. Its tail pointed forward toward the sun instead of trailing behind, and the dust particles defied every model scientists had. Then came the orbital path. 3I Atlas wasn't passing through randomly, it was weaving between planets with striking precision. Venus, then Mars, then Jupiter. Harvard astrophysicist Avi Loeb calculated the odds at roughly 1 in 20,000. To most scientists, 3I Atlas was simply a frozen relic ejected millions of years ago, but to others, it became a puzzle too precise to ignore. When scientists trained their instruments on 3I Atlas, they expected water vapor and carbon compounds, the building blocks of normal comets. What they found rewrote the textbooks. The object was emitting massive amounts of nickel, roughly 4 grams every second. But here's what fractured every model. There was no iron, none at all. In every known comet, iron and nickel are inseparable, born together in stellar cores, sublimating together when heated. It's one of the most fundamental patterns in astrophysics. But 3I Atlas had decoupled them. Even more disturbing, among the nickel emissions, they found nickel tetracarbonyl, a compound so unstable it rarely forms naturally. On Earth, we know it from metallurgical industries and aerospace applications, a molecule that has no business existing in deep space, yet there it was, streaming from an object light years from home. Then came the carbon dioxide. 3I Atlas was venting CO2 in volumes that dwarfed its water vapor. 8 parts CO2 to every part H2O. That ratio doesn't match anything in our database, doesn't align with any solar system body we've catalogued. It points to somewhere cold, violent, and utterly alien. The dust showed polarization patterns never observed before, as if the grains themselves were built differently from anything we'd encountered. Together, these details painted a picture not of a comet, but of something shaped by rules we don't yet understand. 3I Atlas shattered the comfort of certainty. Before its arrival, interstellar objects were theoretical curiosities. Oumuamua gave us a glimpse, Borisov confirmed the pattern, but 3I Atlas gave us something neither could: a genuine window into another star system's chemistry. First, it proved our solar system is not the template. For decades, we assumed other systems would follow similar patterns. 3i Atlas demolished that assumption. Its nickel without iron signature suggests formation conditions radically different from our own. Its CO2-dominated composition points to a colder environment, and its survival hints at structural properties we don't understand. Second, it refined our models of interstellar debris. Scientists now estimate trillions of objects like 3a Atlas roam the galaxy, fragments from planetary systems across the Milky Way. Most will never be detected, but a few will cross our path, each one a messenger from a place we'll never reach. Third, it inspired a new era of detection. Observatories worldwide are now prioritizing interstellar object surveys, and missions like the European Space Agency's Comet interceptor will wait in orbit to race toward the next visitor. But the most profound change wasn't technical, it was philosophical. The scientific mindset shifted from surprise to preparation, from if to when, from isolation to connection. We are part of a vast interstellar ocean, and the currents constantly carry fragments from shores we'll never see. The more we learned, the more it felt like discovery itself was changing. If visitors like this keep finding us, maybe we're not the observers anymore. Maybe we're the observed. Think about what 3i Atlas really represents. A fragment from another world, born under an alien sun, ejected millions of years ago, drifting through darkness while Earth was still forming. By pure cosmic chance, its path intersected ours. For a brief period of time, we are sharing space with a traveler carrying the story of a place we'll never visit. Chemistry we've never encountered, answers to questions we haven't learned to ask. It left us a reminder that our solar system isn't a sealed bubble, it's a waypoint where the past of other worlds briefly intersects our present. If interstellar debris can cross our path this easily, what else might be out there traveling unseen? Maybe that's the real gift of 3i Atlas. Not answers, but the reminder that we're still at the very beginning. 3i Atlas came from the stars and will eventually disappear back into the void, but it leaves behind a legacy, not of answers, but of questions, not of certainty, but of wonder. It reminds us that the universe doesn't play by our rules, that our models are fragile, and that the cosmos is stranger than we've allowed ourselves to believe. When the next visitor comes, and it will, we'll be watching with new eyes, because we've seen what happens when the universe sends a question we're not ready for. If this kind of mystery keeps you awake at night, stick around and subscribe, because this feeling, this sense of standing at the edge of what we know, is only the beginning. And somewhere out there, in the dark between stars, the next fracture is already on its way.